Right, so let's move on to question number 29 again. Right, so consider the following reaction occurring in a rigid closed container. So they have given the reaction and they say the rate of the reaction doubled when the concentration of M was double. So this should remind you that when the concentration of a reactant is double, and if the rate is double, which means the order with respect to this particular reactant is 1. Why? Because when you double the concentration, the rate is double. In the same way, if you remember, when you double the concentration, if the rate is becomes 4 times, then the order with respect to that particular reactant is 2. So the squared, right? But here it says the rate is double when the concentration is double. So this is a first order reaction with respect to M. And they are telling the rate of the reaction is 5 into 10 to the power minus 4 when the concentration of M and Q are 10 to the power minus 5 and 2M respectively. The rate constant of this reaction under these conditions is. So the first thing that I can take is I can write down a rate expression. So I write down R is equal to simple K M concentration to the power 1. Why I have put power 1? Because I know the order with respect to M is now 1. And Q concentration, the gas, to the power X, because I don't know the stoichiometry or the order of the X. Okay, not the stoichiometry, order of the X, I do not know. Right? Then I can write down R is equal to 10 to the power minus 4 is equal to K times 1 into 10 to the power minus 5 to the power 1. Then I do not know the concentration of Q here, but they have given the concentration of Q as 2M. So 2M to the power X. So if I double the concentration, 2 into 10 to the power minus 5, my rate should be double. So that is why I written a 2, another equation, second equation, to understand, to give and understand the idea. So this is what normally happens. But if you remember, I have explained this to you before. We can find the order of a particular reactant in different ways. One of the ways that we do is we keep the concentration of one of the reactants at a constant and higher value so that we can compare that reactant is negligibly participating in the reaction, which means they do not, it is like they do not participate. At that point, the rate only determines by the other reactant. Okay, so this is a condition like that. You see here, the concentration of M is 10 to the power minus 5, very small. The concentration of Q is very, very, very large, 2M. So we can consider this product 2M to the power X times this rate constant, the original rate constant K, combined as K pseudo. I have told you this before. This is a pseudo rate constant. So I can write down this in this particular equation, the first one that they have given the information as 5 into 10 to the power minus 4 is equal to pseudo rate constant times the concentration of the reactant M. Okay, then here there should be a power 1. We don't need to put here because we already know the order is 1. So this K pseudo will be 5 into 10 to the power minus 4 divided by 1 into 10 to the power minus 5, which gives you 50 per second. So this is the correct answer, fourth answer. Okay, so what is the important thing? The important thing is you need to understand the concentration of Q is very large and high. So you don't need to know the order, because we can assume that the concentration change of Q to be constant when the reaction happens.